have two things that have a relationship, you can find the equation connecting them, right? So, and we do that with the linear regression t-test. I think it's number 8. No, it's right here in your exam. Yeah. Testing linear correlation. So that's what we're going to do. So let's go ahead and real quick, let's put this data in L1, this data in L2 on your calculator like usual. So I'll just pop those numbers in there. I'll do it too. I'm going to try to move rapidly through this part because we want to get onto that practice test. And so I'll put them in there real quick. Put them in L1 and L2, and then just go to, stat and tests and the linear regression t-test, right? That's where we do all this kind of stuff. As number 8 says right here, put data in L1, L2, go to linear regression t-test, hit the buttons, and it's just the usual. And we're going to do it on not equals. So if they don't say, we just leave it on not equals. The HO, H1, you can see that on number 8. See how it says in number HOR equals, like always, and the H1 is not equals. So put it on not equals there. So just choose the not equals option. All right, come on down and calculate. Hit the buttons, and what we get is, we get an equation, don't we? We good there? Getting an equation? But we're not going to use that equation. That's the new news. Everybody hearing me on that? Here comes the new wrinkle. The fact is, the p-value for this thing is 0.159. You seeing that? Everybody seeing that p-value? So that p-value is what? High or low? How does it compare to 0.05? Yeah, it's greater than 0.05. It's a high. So the p is not low. So what does that mean? HO does not go away. What was HO? HO was, if you go back, HO is R equals 0, H1's R not equal to 0. So R equals 0, H1 R not equal to 0. So that means we're keeping HO, aren't we? Right? HO does not go away. We keep it. What is HO basically said? That's the linear correlation coefficient, R, right? When R is 0, when the linear correlation coefficient is 0, what does that mean? What I mean to say is, does that mean that the data form a nice line or don't form a nice line when the R is 0? No line, huh? That means they don't, the dots, if we were to look at the scatter plot, you could do that, just hit zoom 9. You would see that the dots don't line up very well at all. That's what this p-value is basically telling us. That, hey, these things don't really make a line. You tracking with me? So, do not use y equals a plus bx. Instead, well then what are we going to do? Instead, and then if you look at your notes right here, here it is. We're really on number 9. Even though 8 was a good beginning. Number 9 is really where you're at on your exam 4 notes. If the p-value is less than 0.05, that's not our case, then there's strong evidence that it's linear. So use the equation, plug in your x, and find y. We're going to do that half the time. On 2 of these 4 problems, the p-value will be below 0.05, and so we will use the equation because they do line up. But on this one, the p is greater than 0.05, which means there's not strong evidence that they line up. So don't use the equation, but instead do that. What is all that? That's basically find the average. First off, is this making sense what we're doing? So one of 2 things needs to happen. It's all about this p-value. If the p-value is less than 0.05, you do one thing. If the p-value is greater than 0.05, you do another. Is that good so far? So the p-value is like a road sign telling us which way to go. So our p-value, 0.159, is greater than 0.05. So instead, so we do not use the equation. Is that making sense there in the exam 4 notes? Instead, what do? hit stat and go to calculate. See what it says, stat calc 1var L2. 1var, and you put in L2 and you hit enter. And you find the X bar, which is the average. I'll do that too. Stat calc 1var L2. Remember, you got a second one. Hit enter. X bar is telling me, what, 88? I have to see it here. 88.6?
I would double check your numbers too. Like the p-value I got 0.0612.
Yeah.
All right. So this is wrong. Let's try that again. 0.061. Yeah, it's still greater than 0.05, but not nearly by so much, huh? So, and now when we do stat calc 1var L2, we'll probably get something different. I'm getting X bar 159.4. 159.4, which is, yeah, beautiful right there.
Okay, so what did I do?
And there we go. So don't miss L2 there.
Did you put L2 for both? Yeah, do you put L2 for and frequency?
One. Yeah, so the list is L2. Yeah, frequency is never anything but 1. Or blank. Maybe leave it blank.
Yeah, just blank.
Just blank. Yeah, just leave the frequency blank. If you have the more fancy, the newer kind. Is that coming out okay?
Yeah.
159.4 on that.
Okay. That makes more sense.
159.4.
I had one L1 and L2 already programmed into it.
It's just making sense now. So, so all four of these are going to be exactly the same. Every one of them, you got to find the p-value, and that tells you whether to use the y equals a plus bx equation or not. Is that making sense? So on this one, the p-value is too high. It's above 0.05. So it's not low. So if that means that it's not linear. So we don't use the linear equation. So do you understand what we're doing? We're trying to predict the left arm from the right arm. Does that make sense what's going on here? We're trying to say, our left arm and the blood pressure in your right arm and the blood pressure in your left arm, are they connected in a linear fashion? Turns out not quite. At least there's not strong evidence for this person, or for these people, that they are. It came out a little bit too high. So therefore we cannot use the linear connection. There's not strong evidence supporting it. So then what did we do instead? We just said, well, you want to know an estimate? See what they're wanting? They're saying, find the best predicted systolic blood pressure in the left arm. Well, if there's no linear connection between the left arm and the right arm, how can we give them the best prediction for the left arm? We just take the average of the left arm values. That's all this 159.4 is. It's the average value of all these left arm values. That's what we told the calculator to do. We said, hey, calculator, calculate the L2, right? L2 is left arm. And give me the average value, please. That's all we're doing. We're just saying, you want me to predict the left arm? I'll just give you the average value. That's the best we can do since there's no connection. Is that making sense? Let's try another one. There'll be two of each kind. Let's try number 2 here. This is some bears. I think we might have done one like this. I don't know. Anyway, the bear's chest size and the bear's weight. And we're wanting to see, is there a linear connection between bear chest size and bear weight? So you know the deal. L1, L2, put the data in there. So put the data in L1 and L2. And then do the linear regression t-test. And I'm getting a p-value like 0.01. You guys getting that? Really low p-value this time. So this is the opposite of the last problem. Got a really low p-value. What does a really low p-value mean? There is a linear connection, huh? You could hit the zoom 9 if you want to see it. The dots are going to really line up nicely. So there's a linear connection between the bear's chest size and the bear's weight. Very much a linear connection. So therefore, use y equals a plus bx, plug in x equals what x value? This one right here, 45 inches. Making sense? So we're going to use the equation. What is the equation? What's the A? Well, it'll be right there on your screen. The A is minus 246.4419643 plus the B, that's the A, and then the B is 11.97991071 times X times the 45. Hit the buttons on your calculator. And I'm getting 292.6. They want me to round. You can tell they're all whole numbers. So that would round to 293 right there. Is that making sense? So we've done it two ways now. And then we'll do the next two problems and they'll be the same things. So on problem number 1, the p-value came out higher than 0.05, which means they're not connected in a line. So we really didn't use the linear equation. Instead, we just found the average of the L2 values. On this one, they are connected in a line, right? The p-value is really low, which means there's strong evidence they do make a line. So we found the line equation that the calculator gave us, the a plus bx. That's the line that fits right through the middle of the dots, right? What's it called? The least squares. I never want to use that. The best fit line. It's got a formal name. But the best fit line. That's the line that fits best through the middle of the dots. Plug that in, 293. Let's try the same thing. Put the data in L1 and L2, and then do linear regression t-test and check out the p-value. One of these on the exam. And even I don't know if it's one where the p-value comes out low or it comes out high. I have several versions of the exam, and they have different ones. I don't know which one you're getting. But you'll get one. There'll be only one, and you need to check the p-value. And if it comes out low, use the equation, y equals a plus bx. If it comes out high, just find the average. So I'm getting the p-value. So I did the linear regression t-test. Linear regression t-test, and I'm getting a p-value. 7.37, but we got that e minus 4 thing. So you know what that means. It goes back 4 places. So that's going to be the decimals right here. But back 1, 2, 3, 4. That brings in 3 zeros, huh? So it's 0.007. So that's certainly a low p-value, isn't it? That's less than 0.05. So what does that mean when you get a really low p-value? You can use the equation. So it's linear. Strong evidence that those dots line up. They have a linear relationship, so we can use y equals a plus bx. So let's do it. Y, and plug in x equals what? 910? 910. This is the bugs chirping and the temperature outside. Do you know that's actually true? That bugs chirp faster as the temperature gets hotter and slower when it's colder. There's a linear relationship. Biologists will tell you. So get your A value. A is 29.63, good enough, plus B. So there's A plus B. B is 0.05007, good enough, times X, 910 there. So Y equals, use your calculator. And I'm getting 75.19, so grab the 75. If you're good, I'm not sure you're good. Please let us know. Crystal can bounce around. I'm glad to help. Let us know. All right, let's do one more. Same thing, L1, L2. Put it in the calculator. So I'm doing the linear regression t-test. And I got a p-value 0.3918. Like we thought, that's a high p-value, huh? That's greater than 0.05, so there's not strong evidence of a linear connection there, right? Those dots do not line up, that means. So do not use the y equals a plus bx equation. You know, it'll give you the a and the b, but it's no good. So instead, just go to stat and calc and 1var and L2, hit enter, and find the average, right? So instead, the best we can do when they don't line up, when the two variables don't have a linear relationship, all we can do is find the average value. It's like a much less desirable situation. So so x bar comes out 6.4666, so 6.5, there it is, 6.5. All that is the average of the viewers. It's just the average of the L2s.